So here is chemical kinetics and welcome to Gita Company. We are going to talk about chemical kinetics. My name is Venkat. I am a Microsoft Most Valuable Professional. Chemical kinetics is a study and discussion of chemical reactions with respect to the reaction rate, the fast, the effect of various variables, the rearrangement of atoms, the formation of intermediates. These are many topics to be discussed, and each of these topics is a tool for the study of chemical reactions. Chemical kinetics reaction mechanism involves the molecules or atoms of reactants must collide with each other in chemical reactions. The molecules must have sufficient energy to initiate the reaction. In some cases, the orientation of the molecules during the collision must also be considered. Molecules must collide with the correct orientation and with enough energy to cause the bond breakage. You are able to see before collision, and here is the collision happening. It's an effective collision. You are able to see it grabs the green color from here after collision. Over here, you are able to see the collision is happening. The collision is happening and doesn't have any changes. So it doesn't have any effects. Let's talk about the reaction rates. The rate of change in the concentration of the reactants and products can be used to characterize the rate of a chemical reaction. The rate of change in the concentration corresponds to with the slope of the concentration time plot. Now further on to reaction rates. Experimental data is used to find the reaction rates, from which rate law and chemical kinetics rate constants are derived by applying the law of mass action. I got my reactants, and I got the product. So reactants gives the product. The rate equation for A and B would be d of A divided by dt is equal to minus K of A to T at the time of T. In other words, the rate of consumption of concentration of A and the production of B at time T is equal to K times the concentration of A at time T. That's rate reaction. Here is the first order reaction. The rate of a zero order reaction is constant and independent of the concentration of reactants. That's your zero order. The rate is K. Whereas the rate of a first order reaction is proportional to the concentration of one reactant. That's your first order reaction. It doesn't have any reaction with the other, and it depends on one reactant. Further, the rate of the second order reaction is straight proportional to the square of a single reactant, or else the product of the concentration of two reactants. So rates of reaction can be determined by monitoring the changes in concentration of either reactants or the product as a function of time. So delta of A versus delta of T. That's it. We got a lot of plus 2 3D physics videos. It's a 8 DVDs pack. You can buy it from Flipkart or GTech website. And you got 10 DVDs pack for chemistry. You can get it from GTech website. And finally, thank you. If you're looking for more videos, you can subscribe in our channel. If you have any doubts, just post it in the YouTube video URL so that we can help you. Thank you.